Welcome back. Today we're going to have a look at the fundamentals of divided by 3, but along the way we're going to learn some ways that we can divide basically any number. We'll start with divided by 3 because it's typically the first one that's just a little bit trickier. When we're dividing by 2 we know our halves. When we're dividing by 5 we can use a 5 times table that we've already learnt. Dividing by 10 is super duper easy. This is the first one where things get just that little bit trickier, so we're going to go right back to the basics. So, first thing I want to show you is a set of 12 things. In this case, it's matches. And you could make a story about this if you wanted. Say we're going on a camp, and I'm teaching you guys how to make your own campfire. I have 12 matches here. You can count them for yourself if you like. But I've got 3 groups that need to learn how to make a fire. So this is my initial set of 12. It looks like this. This is all I've got left in my matchbox that I had earlier on. Now, what am I going to do to make sure that my 3 groups, divided by 3, have the same amount? Now, this is where something called equal sharing comes in, and you've probably done this in class before. You might not have called it divided by, but it's the same process, and this is what we are going to have a go at today. So the first thing I'm going to do to make this super easy for myself is I'm going to say, well, group 1 and group 2 and group 3, these are all groups of people who want to make a campfire, and I've got to give them a fair chance each. I want them to have an equal set made up from this original one. So when I'm dividing by 3, you can see I've got 3 groups. If I was dividing by 4, there'd be 4, so on. But in this case, I want to make sure that my 3 groups get an equal share. So the easiest thing to do in this case is just to spread them out one by one, making sure that each time they get the same amount. So they've started with 1. Now you can see, I'll just move them down so that just the heads are inside there. Each of those 3 groups, from my initial set of 12, if I split them up evenly, each group gets 4. Now, very easy, you say. This is the sort of thing that anyone can do. Absolutely it is. Just so that you know though, the maths would look like this. If I was to write this down in my maths book, it would be 12 matches chopped into 3 groups will give me groups with 4 in each. And that's all divided by is. So when we're doing this equal sharing thing, it's a very easy, practical way to understand how division works. Division is the maths word, looks like this, and this may be the first time you've encountered it, I don't know, depends where you're at. If you're in New Zealand year 3 or 4, you may not have seen that much of this word. I like to think of it as chopped into. That's another sort of graphic way of thinking about it. So I had 12 things and I chopped it into 3 sets with 4 in each. So it's time for you to have a bit of a go. I'll just pause this here and set up a new one and give you a bit of a challenge to see how you go. Okay, so looking at this new problem. In this initial set, we're going to play with Lego today. The boys have been looking forward to it, the boys at my house anyway. So we've got Dave, Liam and George. We've got 3 lads who want to play with Lego. But we have a limited set. In this case, we have 18 pieces of Lego. So the first part of my maths is going to be this. So we know we've got 18 pieces. We know that there's 3 of us who want to use the pieces. That's cool. So if there's 3 of us, we can divide by 3. We're going to chop 18 into 3 sets. Now, I'm going to put this equal symbol here, but basically what this means is that whatever is on this side is going to match what's on this side of the equal sign. So 18 chopped into 3 sets is going to say, well, what is in each of those sets? Well, if we are going to use our equal sharing technique that we learnt just before, it takes a little bit longer, so I might fast forward this bit for you as you watch, but it's going to go like this. I'm going to put one piece at a time in each one. I'm not going to worry about colours, they can swap later if they want to. You know how boys can play together nicely, so just bear with me. Now, we've shared them all out equally. My initial set has been split up amongst the three smaller sets. I was careful to make sure they got the same amount each. It's not really divided by if I just put them in random numbers. There's lots of ways I could split up 18, but when I'm dividing by 3, I'm making sure that there's equal sets of each. So, let's see how many have they got each. It's got 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So, my answer to 18 chopped into 3 sets gives me 6 in each set. Now you might have seen before other types of maths. Maybe you've seen this. 3 times 6 equals 18. Well, there's a reason those 3 digits appear in these two questions. They're in the same family of facts. If I do 3 times 6 is 18, I can also go 6 times 3 is 18. Or I could say 18 divided by 6 equals 3. That's something that we'll have a look at later on, but it's a handy thing to know, because if you know this fact that 18 divided by 3 is 6, you also know 18 divided by 6 is 3. You get some basic facts for free. Okay, here's a new one for you to have a look at. This is the sort of thing you could try at home just with anything you've got. It could be buttons from the sewing kit. It could be Lego pieces like I've used here. It could be toy cars. Anything you like. Noodles. So, here's your initial problem. Now, to save you counting, well, I know that there are 21 Lego pieces in that set. So, I'm just going to get you to pause there, have a go for yourself, come back and see if you can complete the equation. I've got 3 people I want to share it amongst, so the first part of my math is going to look like this. But what's the answer if I split 21 into 3 equal parts? Okay, if you've paused that and you've come back to have a look, see how the answer goes, here we are. Now, let's see. Spread them out little bit by little bit, making sure they have the same amount as I equally share them out. Why don't I just put a whole lot into each one as I go? Well, it's harder to keep track of. If I just do them one at a time, it takes a little bit longer, but then I can be certain that they are getting the same amount each. So, I had 21 to start with. I've chopped them into 3 equal sets. How many do they have in each set? Now, if you've got the answer, don't shout at me, I can't hear you anyway. But you can see that we've made sure they've got the same amount each. I don't need to count each set. I can just count one of them. I can say, well, 1, 2, 3, 4, 5, 6, 7. So that must have 7, that must have 7 in it. So my maths here, 21 divided by 3 is 7. Okay, at some point you're going to say, but Mr. M, what happens if the number that we start with is not divisible by 3? Well, then we're going to have something left over. In mathematics we call that a remainder. So in this set here of more Lego pieces, just single bits, there are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 bits. Now, I've still got 3 lads to share it amongst, and I can equal share to find out what they get each, but you can guess what's going to happen next. Now, we're finished with this one. We'll just put this one aside. Our new math is going to look like this. 10 chopped into 3 sets. Oh dear, that's a wee bit trickier, but don't worry, it's still doable. So we'll go through the steps. Equal sharing, they get the same amount each as far as we can go. Now obviously, because it's such a small amount, it's easy to figure out. Each of the boys get 3 pieces each, but there's 1 left over. Now I can't split that up. You could say, Mr. M, surely you could take a knife to it and split it into 3 equal parts. I could, but then they'd each be useless. I could give 1 extra piece to 1 person, but then that's not fair. What about Dave and Liam? They might want those pieces. So in maths, what we would say then is that 10 divided by 3 gives us 3 in each set, but there's a remainder of 1. That's this little guy here. That's what that remainder is. So when you hear the words remainder, that's all it means, that there's a bit left over that we don't really know what to do with. Now there's ways we can name that remainder. We could find out its decimal, we could find out its fraction. But for the meantime, just calling it remainder 1 is quite helpful. Now this is going to be a useful piece of knowledge later on when we get into other strategies. But for right now, just know that not every number you can divide by 3. So you may have figured out from looking at this page that I've got here, the next thing to do is to learn some basic facts about divided by 3. This is kind of the blunt end of any kind of maths where you just have to remember stuff. But I've got some good news for you. Many of these are very, very easy, and so it only boils down to a few that we may need to spend some time remembering. So what are the easy ones to start with? Well, 3 divided by 3 is 1. Any number divided by itself is just going to be 1. We know, let's see, 30 divided by 3, that's going to be easy as well, because we know any number in the 10 is going to be easy, so that is going to be 10. Another easy one, 33 divided by 3, any double digit number like that has the same number twice, divided by itself is going to give you 11, for example. So 44 divided by 4 would be 11. Then 36 divided by 3, we might come back to that one. Some of the other ones we might know. This is a very common one. 12 divided by 3 is 4. Comes up in maths all the time. 6 divided by 3, there's kind of where your halves go, isn't it? So if I was to chop 6 in half, I would get 3. So the answer must be 2. That's an easy one. Then ones that come up all the time, 15 divided by 3, 5, because that's in your 5 times table, right? 5, 10, 15, yeah, good. 24 divided by 3 isn't too bad. Again, it's a number that crops up in mathematics a lot, and it's because 24 is one of those numbers, is one of the ones you can make up in lots of ways. So in this case the answer is 8. Now it's unlikely, some people find this hard because they go 3 times 8, how can that be a nice even number like that? But it does work out. So because we're multiplying by 8, it makes it an even number. So we're left with a few trickier ones. Depends on your opinion. Let's have a look through. So 9 divided by 3, 3. And you'll notice there's a bit of a pattern emerging here. The answers are 1, 2, 3, 4, 5. 18 divided by 3, 6. We've encountered that one before. 21 divided by 3, we did that just before. 7. 27 divided by 3. 2 and 7 add up to 9. So you know it's in the 9 times table. It must be 9. And then 36 divided by 3. Well, for me, this isn't too bad because I can look at the 30 and say, well, it's 10, and the 6, and it's 2. 10 plus 2 is 12. So those are easy ways to remember those, but that's just in the start. What I would suggest that you do is you go through these several times, practice with your mum and dad, and get those so that you don't even have to think about it. If you can have instant recall of these numbers, it'll make the extra bits that we do later on so much easier. You don't have to go through and count through up in threes and that sort of thing. Skip counting is a valid way to learn in the first place, but what I'd like for you guys is to be able to learn these sets of numbers that belong together off by heart. Not as hard as it sounds. Initially it's a wee bit tricky, but the more you practice, the better you get. So, the message from this part is learn the Basic facts. Not as exciting as some of the other things, but still true.